The examples in this video go with section 6.2, the law of sines. This is part 1. Example 1, solve triangle ABC with angle B equal to 70 degrees, angle C equal to 48 degrees, and side B equal to 15 centimeters. Round the lengths of sides to 1 decimal place. Okay, first thing we're going to do is we're going to draw a picture of our triangle. And I'm just going to put a regular old triangle up here. And I know it looks isosceles, but we know that it's not really supposed to be. Here is angle A, here is angle B, down here is angle C, which they told me was 48 degrees, and angle B up here, which they told me was equal to 70 degrees, and then side B right here, which is equal to 15 centimeters. And we have to find side C, side A, and angle A right here. Well, I think the first thing we should do is probably find angle A. That's probably going to be the easiest thing because I know that all 3 angles in a triangle have to add up to 180 degrees. So if I take 180 and subtract angle B from it and also subtract angle C from it, whatever's left over should be what I get for angle A. So let's put that in the calculator and see what we get. And I am getting 62 degrees. So now we have solved for angle A. Okay, now in order to solve for sides A and C, we're going to have to use the law of sines. Now the law of sines was that the sine of angle A is to side A as the sine of angle B is to side B as the sine of angle C is to side C. And what we can do is we can use this proportion 2 at a time instead of using all 3 of them, and we can solve for the missing parts. And so I think to find angle A, or side A, I'm going to use this part of the proportion right here because I know angle B and side B, they've both been given to me. All right. Therefore, the sine of the angle A we just found, which was 62, divided by side A, which we're looking for, is equal to the sine of angle B, which they gave me to be 70 degrees, divided by side B, which was given to me to be 15 centimeters. Okay, this is a proportion, and I would actually cross multiply to solve this. Over here on the left, we'll have A times the sine of 70 degrees equal to 15 times the sine of 62 degrees. And then since we're solving for A, we can just divide both sides by the sine of 70. That means side A is going to be equal to 15 times the sine of 62 degrees divided by the sine of 70 degrees. And now we're going to put that in the calculator. Make sure you're in degrees before you put it in there. And if I round this to 1 decimal place, I am going to get 14.1 centimeters. All right, now let's find side C. I'm still going to go back up here to the proportion, but to find side C, I'm actually going to use this part of the proportion right here, again, because I know angle B and side B, they were given to me. Now, please know I could use the sine A over A and the sine C over C, but just in case I have figured out this side incorrectly, I'm going to use the given information, and they also had given me angle C there, so this is really good. So all I need to do is set it up and put it into the calculator to solve it. But if I had gotten side A wrong, and I used this proportion to solve for side C, then that means I would get side C incorrect as well because I used incorrect information. So it's always a good idea to use your given information when you can, and only use the information that you calculate yourself when you have to. All right, let's look this up. We're going to have the sine of angle 70 over side B, which is 15, equal to the sine of 48 degrees divided by side C. This is what we're looking for. And again, I have a proportion, so I would cross multiply to solve this. On the left, we'll have c times the sine of 70. On the right, we'll have 15 times the sine of 48. And since we're solving for c, we can divide by this whole thing here, the sine of 70. That means that c is equal to 15 times the sine of 48 divided by the sine of 70. And when we put this in the calculator, again, be sure you're in degrees. You should be though, because we just did this one over here and we were in degrees. So be sure your mode is in degrees before you put it into your calculator. And if I round this to 1 decimal place, I'm getting 11.9 centimeters. And now our triangle is solved. We know all three angles and all three sides. Example 2, solve triangle DEF with angle D equal to 33 degrees, angle E equal to 112 degrees, and side F equal to 16. Round the lengths of the sides to 1 decimal place. All right, let's start off with drawing our picture. Triangle DEF. I'm just going to put angle D here, angle E up here, and angle F down here. Now angle E I know is 112, angle D I know is 33, and side F I know to be 16. So we are looking for side D, side E, and angle F. All right, our proportion would be the sine of angle D is to side D, as the sine of angle E is to side E, as the sine of angle F is to side F. If you take a look at the information that we have here, I know this one, and I can get this one, and I can get this one. So I don't have a complete proportion or a complete ratio here. I'm missing something from each one of these different ratios in here. Here I'm missing the side, here I'm missing the side, here I'm missing the angle. All right, so we can't go ahead and jump into the law of sines. I have to figure out what that third angle is first. So let's get it. Angle F. Remember, all the angles are going to add up to 180, so we should be able to take 180 and subtract angle E and subtract angle D, and whatever's left over will tell me what I have for angle F. And this looks like it's going to be 35 degrees. So angle F is going to be 35. Now I have a complete proportion, complete ratio right here, because I know the angle and I have the side. Okay, let's find side D first. That means we're going to have the sine of angle D is to side D, just as the sine of angle F is to side F. Sorry, we know what side F is, don't we? Try that again. Side F is 16. There we go. Okay. Once again, I would cross multiply to solve this. Over here on the left, we're going to have D times the sine of 35. And on the right, we're going to have 16 times the sine of 33. And since we're solving for side D here, let's divide that sine 35 out. And we'll do it over here as well. Side D is equal to 16 times the sine of 33 degrees divided by the sine of 35 degrees. All right, and let's put that in the calculator and see what we get. Round it out to 1 decimal place, that's going to be 15.2. Okay, so we now know side D, we found angle F. All we need now is side E. And again, I'm going to use the same part of the proportion here, angle F and side F, to figure out what side E is. That means the sine of angle E is to side E as the sine of angle F is to side F. Let's cross multiply to solve. On the left, we'll have E times the sine of 35. And on the right, we'll have 16 times the sine of 112. We're solving for E. Let's divide out that sine of 35. So side E is going to be equal to 16 times the sine of 112 divided by the sine of 35. All right, and let's see what the calculator says. And if we round this to 1 decimal place, I'm getting 25.9. All right, so our triangle is solved. We now know side D and angle D, and side E and angle E, and side F and angle F. Example 3, a triangle has sides of 12 meters and 6 meters, and the angle between them is 76 degrees. Find the area of the triangle and round to 1 decimal place. Okay, let's draw a picture of this. All right, the triangle has sides of 12 and 6, and the angle between them is 76. Now, let's just label this. We have A, B, C, and this side right here is going to be B. Okay. If we want to find the area of this triangle, and by the way, some textbooks will actually use a capital K to signify area, and I think that's because many times when we draw a triangle ABC, and it would be very confusing to have a capital A stand for area and also have a capital A stand for an angle in the triangle. So they usually use the K. I'm not sure, I don't think your textbook actually does that, but just in case you ever see it again in another math class. All right, to find the area, we're going to do 1/2 of side A times side C times the sine of angle B. And we should be able to put this in the calculator and round off to 1 decimal place. Again, be sure your calculator's in degrees. This is giving me 34.9. And our unit is going to be square meters. And remember, we have to square it because it is an area problem. Example 4, to measure the maximum height of the water in a fountain, a trigonometry student measures the angle of elevation of the maximum point to be 25 degrees. At a point 30 feet farther away along the same line of sight, the angle of elevation is 18 degrees. If the eye level of the student is 5.5 feet, find the maximum height of the water and round to the nearest tenth of a foot. All right, let's see what our picture is going to look like here. Let's say we've got our water fountain right here, and this will be the maximum height that the water fountain can be. Right here, this is the line of sight for the student who's hitting the base down there of our fountain. And let's get that angle of elevation in there. So they'll be looking to the top of the fountain. That means the person's going to be looking from here up to that topmost point, and that angle is 25 degrees. And then the student moves backwards 30 feet, so that's going to be back here. And again, from this point, looks at the top or the maximum point of the water in the water fountain, and now the angle of elevation is 18 feet. And we would like to know how tall the water is But also, remember, the student's sight line here is 5.5 feet off the ground. So whatever we get for this side, we're going to have to add 5.5 feet to account for the student's height there. All right. What we're going to do is, I actually have two triangles here. Now I have this one right here, my yellow triangle, where I know one side and I know one angle. But I can get another angle pretty quickly because I know that this is one line right here, and this 125 is going to be supplementary to this angle over here. So let's figure out what this angle is right here. Okay. Now what that's going to do for me in my yellow triangle is it's going to allow me to find this side over here. It's going to allow me to get this tiny angle up here, and it's going to allow me to find this side right here. This is the one that I want because this side is also included in another triangle that I have, which is right here. And the nice thing about my blue triangle is that it is a right triangle. And we know this because our water fountains are going to be built perpendicular to the ground so that the water cycle can continue properly. The water goes up, it falls down, it gets sucked back into the pipes, it goes back up, it comes back down, and so on and so on. The nice thing about the blue triangle is I'll be able to use SOHCAHTOA to solve over here for this side that we're actually looking for. Okay, so since I need to find this one here first, I'm just going to call this M, or any other letter you want to. I'm just not going to call it X because I put the X over here. And I'm going to use my law of sines to figure out what this side is right here. Okay, now side M is actually across from this 18-degree angle right here. And what I need is this little tiny angle up here because that's across from my 30-foot side here. So we need to do two things. I have to find this angle right here, which will help me get to this one, and then I can use the law of sines to find this side right here, side M. Okay. Supplementary means two angles add up to 180 degrees. If I subtract 25 from 180, this is going to give me 155. That means that this angle right here is 155. And if I want to get this little tiny angle up top here, then I should be able to subtract the 18 degrees and the 155 degrees from 180, and that will tell me my little tiny angle up here. And that actually gives me 7 degrees. So this little tiny angle right here is 7 degrees. All right, let's use our law of sines to find our side M now. The sine of 18 degrees is to side M as the sine of 7 degrees is to 30. Let's cross multiply and solve this. On the left, we'll have M times the sine of 7, and on the right, we'll have 30 times the sine of 18. And since we're solving for M, we'll divide out that sine 7 on both sides. And that tells us that M is equal to 30 times the sine of 18 divided by the sine of 7. And let's put that in our calculator, and we're going to round this to the nearest tenth of a foot, which gives me 76.1, and of course this is going to be feet. All right, so now we know side M. All right, let's redraw the blue triangle. We know this angle down here is 25. We just found this side right here to be 76.1. We know we have a right angle down here. We are looking for this side over here. This is where SOHCAHTOA is going to come into play. All right, SOHCAHTOA and the TOA. Now we'll decide which one we want to use, sine, cosine, or tangent. This side right here is the hypotenuse, so we can automatically eliminate the tangent because the tangent only needs the opposite and the adjacent side. And so we just now have to decide between sine and cosine. All right, the side opposite the angle, that's going to be this one over here, the x. And so since this one, cosine, uses the adjacent, we can rule that one out. So this means we're going to use the sine function to solve this triangle. All right, now let's set it up. We have the sine of 25 degrees, and it is equal to the opposite side divided by the hypotenuse. If we put 1 under here, we can cross multiply. We'll have x equal to 76.1 times the sine of 25. Let's put this in the calculator, make sure it's in degrees. And if we round this to the nearest tenths place, I'm looking at 32.2 feet. All right, so that is the length from here to here. And this is, remember, where the person's eyesight was located. Now, the person's eyes are 5.5 feet off the ground, so now if we want to find the height of the water, we're going to have to add that. So we're going to be adding 32.2 feet plus the 5.5 feet for the person, and that's going to give us 38 feet. That means that the maximum height that the water goes is 38 feet. Example 5, an 80-foot flagpole is located at the top of a hill. An observer 220 feet down the hill measures the angle formed by the bottom of the pole to the top of the pole to be 17.7 degrees. Determine the angle of inclination of the hill to the nearest tenth of a degree. All right, so we got our picture drawn for us, and we're looking for this angle right here in the green triangle. And here's the information that we have. Now, notice in our picture, we actually have 3 triangles, okay? We have the smaller green triangle. This one's fairly obvious because they've already colored it in for us, right? And then we also have the top triangle right here, which will go around this way. And then we also have an outer triangle, which goes this way, all the way down like that. And that is actually a right triangle. All right, now I'm going to take all this off because it's a little bit confusing seeing all that in there. But what we're going to do is we're going to work in the white triangle right here on top. I'm going to figure out this angle right here, because if I know that angle, I automatically know this angle right here. This is going to be a right angle because the flagpole, we hope, is planted at a perpendicular, and this perpendicular is continuing down to the bottom of the hill inclination. All right, so we have a right angle. That will give me this entire angle over here, and if I want just the part that's in the green triangle, I'll subtract off the extra 17.7 degrees, and I'll have my angle of inclination. All right, so that's our plan. Let's see if we can put it into effect now. Remember, I'm trying to find that angle up there by the American flag. And since I'm using the white triangle and we don't know for sure we have right angles inside there, I'm going to have to use the law of sines. All right, and just to make it easier, we're going to call that F. This is R, and this is P. So the person's here, this is where our right angle is located, and the flag, of course, is up here. Okay, using the law of sines, I know that the sine of 17.7 degrees is to 80 feet, because 80 is across from that angle. the same way that the sine of angle F is related to the 220 feet, which is across from angle F. All right, to solve this, we'll cross multiply. On the left, we have 80 times the sine of angle F. And on the right, we have 220 times the sine of 17.7. And if we're going to solve for F, let's divide that 80 away. That means the sine of angle F is equal to 220 times the sine of 17.7 over 80. That means that angle F is going to be equal to the inverse sine, because remember, if the sine of the angle is equal to our ratio here, that means that the angle is equal to the inverse sine of our ratio. And that's just the definition for our inverse sine there. So we have 220 sine of 17.7 divided by 80. There's our angle F. That means angle F is equal to, all right, let's put this in the calculator. Again, make sure I'm in degrees. And if I'm rounding this to the nearest tenth of degree, I am looking at 56.8 degrees. That's going to be this entire angle right here. Now remember, we have that extra piece right here, the 17.7, and we only needed the part that was in the green triangle. All right, so our incline is going to be 56.8 minus the 17.7, which will give me 39.1 degrees. And that's going to be the angle of inclination for our hole.